Hello student, hello friend, you are welcome to another lesson. Just use your time to this lesson and then make sure you contribute in a real contribution. At the end, in order to have a full concept, a full understanding about today's lesson. Today we have chemistry practical, advanced practicals of chemistry, and today we are continuing with our lesson Redox titration. It means in one reaction there is two reactions, oxidation and reduction. So we'll be together here. Take your pen, take your exercise book, and then make sure you note important notes about our lesson at the end of the lesson in order to understand completely. And after understanding, you'll be able to answer the different questions which are relating with this lesson or this experiment. So today, our objectives of our lesson, you will know at the end of the lesson, you will know or will be able to understand to calculate the volume strength of hydrogen peroxide. Make sure at the end of this lesson you understand how to solve volume strength of hydrogen peroxide. This is advanced practical. What is volume strength of hydrogen peroxide? Can you try to think about the volume strength? The volume strength is the volume of oxygen in a liter at standard temperature and pressure would be liberated with 1 liter of hydrogen peroxide when it decomposes. It means hydrogen peroxide after decomposition is going to give oxygen and water. So the volume strength of hydrogen peroxide is the volume of hydrogen gas or hydrogen in 1 liter that liberated after decomposition of 1 liter of hydrogen peroxide. That is volume strength. I think you have understood about the volume strength to our lesson. So after having the definition or after understanding the volume strength of hydrogen peroxide, we go to our experiment for today. This practical, when you cross-check the practical performed in 2019 Chemistry Form 6 National Examination, Chemistry 3A, was this question. This question guided or asked you to calculate the volume strength of hydrogen peroxide. So how can you solve? After performing the experiment, you're going to calculate the volume strength. So how can you solve this question? I think you still be together here. You will know. Our reactant for today, we have potassium permanganate and we have hydrogen peroxide and we have sulfuric acid. The titrant is this one, and the hydrogen peroxide. But sulfuric acid is here in order to initiate acidic medium within our reaction, because the redox reaction cannot react without in acidic medium. I think for the previous lesson, I have described this, and I have shown balanced the equation overall from half to half reduction, half oxidation. I have shown it on that lesson. So for today, let's go to solve the question, and I will describe the procedure. It means we have potassium permanganate, this one. We have potassium permanganate. This is pink color. And we have hydrogen peroxide. We have hydrogen peroxide, this one. And also we have sulfuric acid as written there. So in case of procedure, the potassium permanganate will be in a burette. Potassium permanganate will be in a burette, this one. Do you see? This one. This is potassium permanganate will be in a burette. And then another reactants, hydrogen peroxide. Hydrogen peroxide will be in a conical flask, and we are going to add sulfuric acid in order to allow the acidic medium which will react with the manganate or manganese for oxide. So that is our procedure. So one step by one, I will show you, and I will show you the ending color of our experiment. Let's restart. After filling the burette, then we are going to pipette, or we can measure by using measuring cylinder of 50. Don't use 100, because 100 is large with the 25. So we have to pipette or to measure hydrogen peroxide. And then we pour in a conical flask. This one we pour in a conical flask. And we add the same amount, the same volume of sulfuric acid, and the same solution of hydrogen peroxide. Then we add. So hydrogen peroxide added with the sulfuric acid, and then we are going to titrate. So I will show you the ending color. The initial volume is 0, and what was ending color? I'm going to titrate. I will go fast into the time, but we will see the ending color. Don't look above, because the color will show you where you are going to stop. I have no bench here, so that's it. I use technically in order to be correct. But if you have a bench, you have to use both hands. It means one drop, one by one you shake. One drop, you shake. One drop, you shake. You see, the pink color is coming and they disappear. Coming and they disappeared. Coming and disappeared. So you see the ending color change with this one. So this is pink color. This is pink color. So my volume here is 25. Is 25. So that is ending point for our titration. After looking this one, it means we have noted the volume is 25. Volume of this was 25.0. This is the ending curve. So after getting the volume, we have to calculate our objective of our lesson, the volume strength of hydrogen peroxide. I think we are together from the starting up to this time. Do you have understand? You have a question? Hello my friends, do you have a question? Just allow me to proceed. Okay, after titration, and then we are going to solve. The first question is, write balanced equation. The balanced equation means between this one and this one and acidic medium. It means in a conical flask, it means this one, the reaction, manganese for oxide react with hydrogen, acidic medium. The product is manganese 2 plus water. I put direct and go fast in order to be together. I think previous lesson I have described this, so I think you will see that lesson, and then or you can find that lesson, and then you understand more about the action. When you balance here there is 8, and here there is. But in terms of balancing, it means it will be manganese balancing the ions plus 8. Here there is negative plus 5 is equal to manganese plus water. That is our half reaction for reduction. And for oxidation, there is hydrogen peroxide. Hydrogen peroxide. It means hydrogen peroxide will be. This is for reduction. You can note this one, and then we proceed with our half oxidation reaction. That note it, and then to proceed in a few seconds. I think you have noted. Let's proceed. It means half oxidation will be hydrogen peroxide. This is oxidation. Half oxidation reaction. Peroxide decomposed to oxygen as hydrogen ion within our reaction. So here there is 2, but here is 2. So in order to balance the ions, you have to add 2 ions. That is our half-full oxidation. You can note it, and then you proceed to overall. When you put half reduction, it means manganese 4 oxide react with 8 hydrogen ion, react with 5, means the product will be this one plus 4 water. Then for this and this one, you have to create overall reaction. You have to create overall reaction. So it means this one, we consider this and this. This will come to this side. This side, here there is 5. And here there is 2. It means overall reaction will be manganese, 2 manganese oxide plus 16 hydrogen ion plus 5 plus 10. But you can cancel through this reaction. It means this will cancel with this one. It means this will be 10. This will be 10, means almost we're going to cancel 30 ions. Are we together? Okay? So, by taking this one, this is over, we go to the side. It will be 5 hydrogen peroxide react. Yes, that is over. We go to the product. This and this one will be positive plus 80 water. 80 water plus 5 oxygen and the 10 hydrogen ion. So this is overall reaction already calculated or already shown. Balance the equation, half and the overall. So molar ratio, we have 2 ratio 5. That is balance the equation for our redox reaction between potassium permanganate and the hydrogen peroxide. But don't forget, our objectives is not yet calculated. That is balance the equation. Then we proceed. Take a note about this to proceed in another section. I think you have already noted. Then we proceed. So apart from balance the equation of all half reaction, half oxidation, half reduction, and overall reaction, let's proceed with our objective is volume strength. I remind you again. After getting the end point not a color, this helped us to find the molarity of unknown. So it means this is already calculated. When you cross-check the paper of 2019, you can, it means solution V was 0.05 after dilution formula, 0.02. And after calculating by using molar ratio formula, it means molar ratio formula, it means our formula will be M, molarity of U, W, volume W, N double V is equal to molarity of double V, volume of double V times W. It means you are required to find the molarity of double V. When you calculate, after balancing the equation, you have C molar ratio is 2:5. When you calculate, it means molarity of this one, is equal to 0.05 m. After solving, you can use your time to solve this one. That is our formula, molar ratio formula. So apart from that, we are going to solve volume strength. So be careful, be responsible, contribute with your mind, full mind, and then you will understand. This is volume. This is molarity of hydrogen peroxide after titration. It means this is diluted. So we go to calculate volume strength. When you look at this paper, a question C, letter C was asked B. Using the result obtained in B, it means molarity of V, calculate the volume strength of commercial hydrogen peroxide. Volume strength of commercial hydrogen peroxide. It means commercial is a solution concentrated. It means in a stock solution. As we are going to buy a concentrated hydrogen peroxide, that is commercial sample. So when you find these molarities, just cross-check this one. The solution B made by diluting 38.9 commercial sample up to a half liter. So it means the commercial content diluted by adding water to this one up to a half liter. Then after titration, we have got molarity this one. So in order to calculate the volume strength, you have to solve the molarity of commercial sample. Because we have diluted, you have volume of concentrated, diluted, or added with the water, and you have the volume of water reached after adding the water. So you have to calculate the commercial molarity or sample of hydrogen peroxide. So how can you solve? You have to solve through the formula of dilution formula. VC is equal to MD VD. It means MC is required. VC is equal to this one. VC is this one. And the MD is a molarity of 0.05 calculated to here. And the volume of D is 500 of solution, this one. So data we have is this one. We have to calculate MC. It means molarity of commercial. Without this, you can't find the volume strength. So it means MD is equal to 0.05 times volume of diluted is this one over volume of concentrated, which is 13.9. So when you solve this one, 0.05 times 500 divided by 13.9, the answer is 1.799 after approximation. that is MC. Then, so MC is this one, 1.799 or 985. That is commercial molarity. So after reaching here, if you'll be asked to calculate the initial concentration, it means will be times with the molar mass of hydrogen peroxide, which is 34 gram per mole. It means times this one will get initial concentration, but this was the final concentration after dilution, because initial concentration will be higher than final. It means final is diluted. So you can use this one because our question is not guided. But when you times this one, you will get this is final concentration. This is initial concentration. So you have to use commercial sample molarity to calculate the volume strength of our hydrogen peroxide. Do you catch me? We have understand this. After calculating the molarity of potassium magnet, we find the molarity of hydrogen peroxide. We use that molarity by using this data of dilution, by using dilution formula, also to calculate the molarity of commercial, or is molar concentrated before diluting or stock solution. So after having the MC, that's you are going to calculate the volume strength of hydrogen peroxide. So in a few minutes, I will come here again to show you how to calculate that volume strength of hydrogen peroxide. So welcome back again to our lesson. We are proceeding with how to calculate volume strength of our hydrogen peroxide. After having commercial, we have two ways, I have said. The first we use this commercial molarities. So we use, or we can say this is a mole. So volume strength is calculated in that way. You have to pass through the composition of this one, hydrogen peroxide reactive composition to give water. So when you balance, this is balanced. So you have to look. It means 1 mole. I have said the volume strength is the volume of oxygen at the S.t.p. is going to have this one, 1 mole. The volume will be 22.4 decimeter cube. So, how many mole of this one will give the volume? It means 1.799 with our. So we find the volume. And our answer will be the volume strength. So 22.4 times 1.799 divided by 2. The answer will be 20.15. So, according to this answer, the volume strength of hydrogen peroxide is this one, 20.115. And that is how to calculate volume strength in one way. For the same this one, you can use initial concentration. It It means in order to get concentration here, you times molar mass. It means 34. When you get 34 here, 1.799 times 34, you get 61. 61.17. This is a gram per mole. So it means even when you are going to use mass, you are going to change this one. It means in that case, you calculate in this way. It means this one will be, when you balance here there is 2, sorry. Here there was 2 more. Sorry for the first calculations. It means it was 2 more. It will react with this one. And here there is 1.79 was X. It means this one and this one divided by 2 more. Thus we have got 20. So in case of mass, it means we remove moles, use mass. Use mass. It means, consider here, when you have the mass here, it means 34 will be 68 gram, related with this one, the same. But this one, how many will be? 61.17. How many will bring the volume of oxygen? 68 times, 61.17 times 22.4 divided by 68. The answer will be the same. Is equal to 20.150. So through 2 ways, the answer are the same. I think our objectives have been understood. We have understood our objective. At the end of this lesson, we'll be able to calculate with the question, the volume of strength of hydrogen peroxide. You can pass through the same paper of 2013. You will meet this question. But in paper 13, on dilution was said the solution diluted times 36. It means on your formula of V1, it means V1 diluted times 36. It means it will be 36V. So it means V1. So when you put VC over VC, so when you equate the formula on that paper, MC, it means MC is equal to VB over VC. It means there on the paper 13, the volume of diluted was not written as this question. It was said the volume diluted up to 36 times. So it means it was the VC times 36. So it means it was the VC times the 36. So it means this one will cancel with this one. So it means we remain empty after calculating molarity of of your solution, hydrogen peroxide, you times this one, then you get molarity of concentrate. That was the question 20 and the 8 and the 13. Yes, that is our concept. So when you take a paper, you receive the question and then you use the same calculations, same procedure to solve that question. I think now we end up here for our lesson. Thank you for your contribution. You student, I think you have understood about how to calculate volume strength of hydrogen peroxide. This is advanced chemistry practicals, Redox titration. I thank you more. We together on another lesson to understand more different topics. My name is Mr. Maguru. I'm dealing with physics, chemistry, and the biology practicals. You can ask questions. You need a notes, you need a sample of questions with the answers. You will get it. Thank you for your time. Another time, another day.